Okay, to prep you for the 1.21 quiz, if you haven't already, make sure you read lessons 1.19 and 1.20. But here are some key points from 1.19 that I want to make sure you are familiar with. So the parts of a graph, and then how to interpret a graph. So here's a just kind of generic graph setup, all right? And things you should be able to identify are going to be things like your x-axis, your y-axis, independent variable, dependent variable, which these we're going to define in 1.20. Your data points, your slope, your trend line, that sort of thing. All right, so some of this should hopefully be an easy review from a math sort of class, but your x is always the horizontal axis. Your y is always the vertical axis. All right. Independent variable always goes on your x-axis. Dependent variable always goes on your y-axis. All right. So this is the independent variable is time, and your dependent variable is count rate. All right. Your data points, those are pretty obvious. Those are going to be your dots here. Whoops. Not mean to make that smaller. All right, so that's the dots. The slope is going to be this number here. All right, we're going to talk about how you calculate the slope, but really the slope is related to your trend line. It's a value that tells you what that trend line is. All right, and that trend line is that straight line, the line of best fit. All right, it's not a connect the dots. As you can see here, it's a single straight line that goes through the center of the space of your dots, but it won't necessarily hit all the data points, and that's okay. All right, because what we're looking for is kind of what is the general trend of our data. And you can see in this particular case, as time increases, the count rate goes down. So our trend is downwards, which is why that slope is negative. Last slide here, the title was count rate versus time. All right, so it was what was on your y-axis versus what was on your x-axis. And another thing to discuss is your titles. All right, so rule to that, your title should always be your dependent variable versus your independent variable, or your dependent variable as your independent variable changes. All right, so it's always going to be y versus x. All right, so just to kind of practice that, this first graph, we've got degrees in Fahrenheit on the y-axis and day on the x-axis. So if I were to title this, I would call this temperature by day or something like that, or temperature versus day. All right, temperature is on my y-axis, that's my dependent variable, that's got to come first, versus what's on my x-axis, or my independent variable. So see if you can title the next one. So hopefully you've had a chance to think about it. You might have said minimum wage versus year, all right? Or you could even say like salary versus year or salary by year. So I'm just going to abbreviate minimum wage by year, all right? Just know that the first thing in your title is what goes on your y-axis. So slope. All right, some of you guys may be familiar with the phrase rise over run, which is great if your x-axis and your y-axis are in the same count. All right, you know, everything is increasing by 1 on both axes, which means that the two graphs that I have here would work. You could use rise over run, but I know on your Unit 1 test part 2, that's not going to be the case. So this slope is something you need to use, this slope calculation. So real quick, I just want to show that to you. What this equation means is that you need 2 points off of your graph. All right, the first point will be x1, y1. Got a comma in there. Second point will be x2, y2. All right. So, and I mean, you can choose any 2 points. A general just kind of thing that generally is suggested as good practice is to choose 2 points that are pretty far from each other on the graph. So I'm going to choose, if I can get this to right, these 2. They're pretty far apart from each other, so I would say that's 2, 2. Oops. And 9, 9. All right, and then what you end up doing is you take your y values. All right, so y2 is 9, y1 is 2. You subtract those and then divide it by the x value subtracted. All right, so that's how I get 7 over 7, which is 1. All right, positive 1. The other graph, all right, I'm going to choose slightly different points. And I'll use a different color for this one. Let's do these ones. They're still pretty far apart. I've got my my x1, y1 is going to be 2, 8. And then 7, 3. All right. So, oops. Ignore that there. So there's, sorry. My x1, y1, my x2, y2. So now I'm going to plug that in. So I'm going to have 3 minus 8 over 7 minus 2. All right, it's important that you make sure to always use the same points for the first part of the calculation so you get your signs right. So 3 minus 8 is going to be negative 5 over positive 5, or that ends up being a slope of negative 1. All right. So positive slopes show you that as your x-axis increases, your y-axis is going to go up too. So as your independent variable is increasing, so is your dependent variable. Negative slopes show an inverse relationship. So as the independent variable, or the x, increases, the dependent variable is going to decrease or go down. And then one last thing related to interpreting trend lines and slopes. I want you to kind of think about this one. So every once in a while you might run into some data like this. So what would the slope of this line be? If you're not sure right off just looking at it, choose 2 points and calculate it out. So I've got negative 3 and 2, and then I have 3 and 2. All right, so I'm going to have 2 minus 2 over 3 minus negative 3, which is going to be 0 over 6, or 0. All right, so a flat horizontal line like this means that your slope is 0. If your slope is 0, if you notice, your y value isn't changing. It's always 2. All right, so what that means is that your independent variable has no effect on your dependent variable. All right, so as your independent variable, as your x increases, the dependent variable or your y value doesn't change.